Okay, pure free in 33 minutes, okay? Please watch P1 and P2 videos as well. It's so important because you need all of that prior knowledge. Best of luck in your exam. Good luck, guys. Okay, chapter 1, algebraic methods. Now, I highly suggest you go and watch my pure 1 and pure 2 videos as well, okay, as this, because it will help. They're only 15 and 26 minutes long. Then, what we need to remember is if we have a number on the numerator, our degree here is 3, okay? And on our denominator, if it's the same or less, so our highest degree here is 3, we have a top-heavy fraction, so remember that. So this is going to be improper, okay? So when you do your dividing, the I'm a silly Billy, the long division, however you do it, remember if we're dividing by x cubed plus 4x, oops, let's put a 5 here. We have x cubed plus 4x plus 5. Okay, whatever this is going to be like your ax plus b, whatever. And then your remainder, sorry, I'm trying to do this so fast. Your remainder is going to go here. And it's going to be divided by our denominator of the original one. So that's nice and easy, okay? These questions are normally found when you are integrating, differentiating, when you need to simplify something. So don't be worried about, sometimes they're standalone, sometimes they're not. And you need all your P1 and P2 knowledge. Okay, functions and graph, probably the biggest chapter. I remember the modulus spits out the positive of whatever this is. So you know this is 5. Okay, a few things to do. When you draw the graph, always draw the graph at normal, and then whatever you're reflecting. So for example, if you're drawing the graph of y equals 2x plus 5, for example. So you know that this crosses at 5 and it has a gradient of 2. Okay, if I'm drawing the modulus of this, that means my y is going to be positive. Y is positive always above the x-axis. So you're just going to reflect that up here, okay? Sketching, again, you need all your P1 and P2 knowledge here. Make sure you are happy with that. What it loves to do as well, don't be afraid to sketch, okay? Because they'll give you this one, and then they'll also give you, well, y also equals, let's do negative x plus 3. Okay, negative x plus 3 is going to give us this line. And it's going to say, where do they cross? And we're going to have to find the two values. Okay, so this is how to do it. You're going to have two equations. Number 1, you're going to have 2x plus 5 equals minus x plus 3. Okay, because we're going to take the positive. This positive here is going to give me this equation. Then number 2, you're going to have you multiply everything in the modulus by negative 1. So we're going to have negative 2x minus 5 equals minus x plus 3. I don't multiply anything here because it's not in a modulus bracket, okay? And then this is going to give me where it crosses here, okay? You solve them, you're going to get your x, substitute in to get your y. Nice and simple. A few favourites that they also like to do is they like to know, so if we're sketching the graph, if we're sketching the graph of y equals f of x, okay, what is that, right? It means it's the same as what we normally do, okay? So if you're sketching the graph, whatever it is, like this, okay? Anything below, we're going to reflect up. Nice and easy. Then, if though we're sketching the graph of y equals f of modulus x, okay, and remember it's the x that's the modulus. Imagine we had our graph here. I'm just going to change it a bit. I'm going to do this. Okay, so this is our graph. Now, modulus x means I reflect anything on the positive x side in the y-axis. So this is what I have. I don't care what's on the left of it. So this, whatever's on the left, I don't care about. And I'm just going to reflect that again in the y-axis, okay? So it's like I've completely forgotten about this part of the graph. I don't really care about it. Then all you need to know as well is functions, which you should be able to do. Again, this is GCSE, you know, if it's inside the bracket, who does it affect? X, we do the opposite. If it's outside the bracket, who does it affect? Y, we do what it says, okay? Really nice. And with this, it's a case of just reading the questions. It's basically transformations of graphs with just modulus added in. Nice and easy. Okay, trigonometry, right, so there is a lot for you to remember here. What do we know? We know that sec is 1 over cos, and again, we're close to the exam. Last letter is going to help you figure this out. So cosec is 1 over sine. The third letter is going to remind you, and cot of x is 1 over tan, or we know that tan is silly cow, so tan is technically 1 over sine over cos, which we know is cos over sine. Okay, so just remember those. Now, you have to remember the following rules. I always forget these, but what I know, I'm not going to write this fully because I'm going to show you how quick I do this in the exam. I know that sine squared plus cos squared equals 1. If I divide it all by sine, okay, sine over sine is 1. Cos over sine is cot. And 1 over sine is cosec. This is how I remember this identity, that 1 plus cot squared equals cosec squared. Then I do the same again, but this time I know that sine squared plus cos squared equals 1. I divide everything by cos. Okay, sine over cos. What is that? That is, where's sine over cos? Tan. Oh my golly. Tan. So that is tan squared plus cos over cos is 1. 1 over cos we know is sec squared, okay? So there we go. We've worked out these two without having to remember them. So if you've forgotten how to remember them, don't worry, you can quickly work them out. So we need to know that. What else do we need to know? We need to know how to draw these functions, okay? So sec, cosec, and cot. Basically, we know that cos, this is sine. Oh my. This is sine, okay? So we know that 1 over is going to be here and here, isn't it? Okay? And what we're going to have is our asymptotes. Here we are, right? This is nice and easy. The same for cosec. You do the same, you just do the opposite. Tan is slightly different, where we know that our normal tan graph looks like this. We're just going to do like that, okay? But the asymptotes are the same. So that should be lovely and easy. The other ones we need to know as well is the arc function. So the arc function is actually, arc sine is actually when we do the sine minus 1 in our calculator. That's what it is. So arc sine is the inverse, and let's just get this straight. This is the inverse of what sine is. Now, inverse with the graphs, remember, they are always a reflection in the line y equals x. So when we have our sine graph here, it looks like this, etc. Imagine the line y equals x goes through here. It is that reflection, okay? So in this reflection, what are we going to have? It's going to go up here, down here, okay? And this is now your pi over 2, your 1, your minus 1, and your negative, negative pi over 2. Okay, same for arc cos, by the way. It's going to cross here. This is your pi over 2. This is your 1, minus 1. Okay, and then arc tan, you just have to remember. Now, I haven't seen these come up in ages, to be honest with you, but it's just good to have a quick refresh, I suppose. This is pi over 2, negative pi over 2, and 0. Okay, now, sometimes they love those questions, don't they? In this chapter where they say solve it, but they have like the prove the arc cos x equals arc tan of like root 1 minus x squared over x, for example, yeah? So what do we know in these types of questions when we're proving these arc questions? It's all about manipulation. It's literally manipulation. So all I want to see you do is manipulate. Okay, so what is x? Okay, so you know that cos of x squared, what does that equal? That equals 1 minus sine squared x, does it not? Okay, how do you get rid of a cos squared? We square root. So we now know that cos of x equals the square root of 1 minus sine squared x. Okay, but what is cos of x? Arc cos of x is my inverse. Okay, so this is how I'm going to get my inverse. So I know that to get my inverse, I inverse both sides. This becomes arc cos. This is showing you that I have now 1 minus sine squared x. I've now inverse this. Okay? How can we use that to help us, and then you can manipulate, rearrange, etc. But what I'm saying is you will have all the answers in these types of questions. These are like some of the harder ones. Again, more than likely what comes up is these ones where you prove that sine x over 1 plus cos x plus 1 plus cos x over sine x equals 2 cosec x, okay? And then you've got to use your manipulation. Remember, when you're adding fractions, you need to have the same denominator. And then it might say solve, I don't know, it might say solve this for something in the interval. Again, back to P2. Okay, so nice and simple there. Okay, so question three, oh my golly, chapter 4. So this is where we still need all the information we needed from chapter 1. However, there's a slight difference here, we get the R formula, double angle formula in addition. You do not need to learn the double angle formula, because the double angle formula is essentially saying that this is also A, so you can work that out here. Sine of A plus A is 2A, right? So this is sine A, cos A, plus cos A, sine A. Okay, nice and simple, which is 2 sine A, cos A. Okay, the other formulas you can get from this as well is when you do the cos A of cos A plus A, you know that this is the same as cos squared A minus sine squared A. And then using the formula cos squared plus sine squared equals 1, you can also get the 2 cos squared A minus 1, or 1 minus 2 sine squared A. Again, okay, you can work this all out. Same with the tan. You can work out that this is 2 tan A over 1 minus tan squared A. Okay, so make sure you're happy with these types of rearranging. You do not have to remember them. Okay, they are here, you can work them out. Now again, that these types of questions, it will be solved, when you've got to use the double angle formula. Really simple, you guys can do it. Manipulate, solve it. Something they love doing as well is like cos 4 minus sine 4. This is the difference of two squares. This is cos squared minus sine squared and cos squared plus sine squared. And what do we know about cos squared plus sine squared? This equals 1. Okay? So make sure you watch out for those. Watch out for the denominators. Watch out for those types of questions. Now, the other thing that's on this chapter, and I love this, is the R cos or R sine. We have the R sine and we have our X plus or minus our alpha. So depending if it's sine or cos, remember, you're going to be using this. Okay, and we're going to be doing matchings. So what do we know? I'll say express this, blah, blah, show that it can be written in this form. Okay, so for example, if we had 7 cos 2 theta plus 24 sine 2 theta, and write it in the form of sine or cos, whatever it says. Okay, well, if it says write it in the form of sine, well, what do we know about sine? Okay, we have our x plus alpha, theta, should we call it? Okay. Oh no, this is going to be alpha. This is our 2 theta here. Okay, so we can see this is our A, this is our B. So we know we're going to have sine of 2 theta cos of alpha plus cos of 2 theta sine of alpha. Okay, this is literally a matching game. I should have written this the other way around. This cos 2 theta matches here. And what do I find? I find that 7 is sine alpha. Then this literally matches here, okay? And that cos alpha is actually 24. This is really lovely because that means that sine alpha is 7 and cos alpha is 24. Okay, how do I find the angle? I do tan. What's tan? Sine over cos. What's sine? 7. Cos, 24. Inverse it. Then you get the angle. How do you find your r? This is using the sine squared plus cos squared equals r squared. Okay, so what is sine squared? 7 squared plus 24 squared, square root it. It's like Pythagoras. Really simple, okay? These ones are so easy. Then once you've done that, you can solve it. Remember, you're manipulating to get it into this, and then you can solve. You have everything you need up here. Okay, chapter 5, what we've got, exponentials and logs. Now, this is the only thing that they give you in the formula, okay? And it's just a reminder. Make sure that you just get the ln on its own, okay? Like if you had ln a to the 2, that's not going to work, okay? Bring the 2 down. Now, what is in this chapter? I've completely forgotten. Sorry, 1 second. All right, so in this chapter, we have exponential graphs, which you should be able to do. Differentiation. Okay, that's fine. I'm going to cover this in a minute. And sketching the graphs. You know how to sketch the graph of e to the x, okay? So e to the x, what is that? E to the x looks like this, and it crosses at 0, 1, okay? And then you can do your functions. Right, log to the base e, or our ln graph, okay? Remember, ln is the inverse. What did I say about inverse earlier? That they are reflections in the line y equals x, okay? So our ln graph looks like this, okay? And what is this point here? This is 0, no, this is 1, 0. Okay, so just remember that. So you can do the transformations of this, no problem. This is mainly solving equations. Sometimes you get the solving one, so you've got to remember, okay? Like if we have e to the 2x plus 5e to the x minus 14. What is this? A hidden quadratic, guys. Look out for the hidden quadratics, all right? If you had e's on both sides, like e to the 2x equals 11, for example, how do you get rid of an e? You log it. So then you have ln of 2x equals ln of 11. Okay, so it's just remembering that kind of stuff. Remember, can we learn a negative or can't we learn a negative, you know? And we can't, we know that from the graph, like we can't log. The other thing is sometimes, and this doesn't come up every year, by the way, this is, you know, our log of x graph, and then we have our log of y graph, and then log of a, okay, and here it crosses, right? If this is in the form y equals ax to the n, what we've done here is we've logged everything. So essentially, log of y equals log of ax to the n. How do we, using log laws, log of a plus log of x, again, log of a, to the power of n, plus n log of x. Okay. Your log of a is your y-intercept and your n is your gradient. Make sure you remember that. You can quickly figure this out, all right? You can quickly figure this out. And even if there's not logs, you can do the same when, you know, you have the formula y equals ab to the x. It normally tells you in the question what they want and how to do it. But if you don't know that it looks like this after you've manipulated it, you can quickly manipulate it. And then if it wants you to find out what a is, okay, you can, sometimes you do like comparisons, and then like maybe you'd e, or, you know, like to the power. There's loads of different things. I hope that one made sense. Oh yeah, so sometimes as well, actually, so they'll give you points. So they'll tell you like this is 0, 2, this is 20, 2.2. So straight away you know that 2 is your log of a, because that's the intercept. So you know that log of a is 2. Now obviously if the base is 10 when we don't have a base, so we know that 10 to the power of 2 is equal to a. So we can already put that here. your gradient using 2 points, y1 minus, or y2 minus y1 over x2 minus x1, and then you're going to get that equals your n. Like, you can manipulate things and it will tell you in the question what's going on. Okay, one of my favourite chapters right now, differentiation. Right, let's just go through some of the facts you for sure need to know. Okay, I love using this method. So if I'm differentiating sine and cos, I've got sine, cos, minus cos. So sine differentiates to cos differentiates to minus sine differentiates to minus cos differentiates to sine. So I literally write that in the corner. And that is easy, okay? Then what we have to look at now is e to the x. E to the x differentiates to e to the x, okay? And then if y equals ln x, that differentiates to 1 over x, okay? So these are a few things that we definitely need to know. The only thing that happens is when we start putting our k's, okay, when we start getting our k's here, like sine of 4x, this is where the chain rule comes in. Now, my chain rule, I don't use a formula. I literally just go with what I know. So sine of 4x, for example. How do I differentiate that? Sine differentiates to cos, okay? So I get cos of whatever the bracket is, multiplied by the differential of the bracket. So I differentiate 4x now. So I multiply that by 4. So I get 4 cos 4x. That is the chain rule. The chain rule basically means whatever's inside your bracket, leave it like you would. Like you could put your finger over it and just think, how would I differentiate? Then whatever's inside your bracket, you multiply by that. Some people like to use substitution, etc. And what they do is whatever's in the bracket, they label that u. And that can work, and I'm all for that. For example, cos of u. Okay, what does that differentiate to? To minus sine of u. However, we then need to multiply that. What was our u? If our u is 4x, we're going to multiply that by the differential of u. So you might see that formula that goes dy by dx equals dy by du times du by, dy by du times du by dx. Either way, okay, I don't mind what you do as long as you understand what chain rule is. Remember, they give you some stuff here, so watch out for those, okay? And they actually give you, I didn't realise they gave you quotient rule. That's insane. Okay, so what is next? After chain rule, we have product rule. So a product is literally a product. Okay, this is a product. We're multiplying two functions together. And you label them v and u, and you do v multiplied by the differential of u plus u multiplied by the differential of v. So v du plus u dv. So here, we're going to have, what is my v? X squared multiplied by, what is the differential of ex? Plus, what is my u? Ex. What's the differential of x squared? 2x, okay? And then I could simplify, etc. Then, quotient rule. I do the same thing, but I do v du minus u dv over v squared. Now, it's really important, whatever function you have, okay, you could also remember that you could have chain rule within this as well. It's the denominator is always v. Okay, so you can remember it as u are always on top, but you actually get given this formula, so that's nice and easy. Then, yeah, tan goes to sec squared, sec goes to sec tan, cot goes to minus, etc. Okay, so you get given those, that's fine. Watch out for them. Oh, what else? Oh, yeah, so y equals arc sine x means that my differential is 1 over the square root of 1 minus x squared. Now, how does that happen? Okay, this goes because y equals, how do I get rid of the arc? I would essentially sine both sides, right? So sine of y equals x. Okay, that's lovely. So now to differentiate sine of y, how would I differentiate that? Okay, because I need to differentiate it, don't I? Instead of doing dy by dx, I do dx by dy. Remember, this is going to be 1 over, okay? So it's 1 over, essentially, when I go back to my y by dx. So dx by dy means essentially I'm differentiating x with respect to y. What's the differential of sine? Differential of sine is cos of y, okay? Now, I don't want dx by dy, I want dy by dx. dy by dx is 1 over cos of y. And then going back to that arctan manipulation again, what do we know? We know that, using what we know that sine squared of y plus cos squared of y equals 1, right? We know what sine y is, don't we? It's x. And we've got a cos y here, so I'm going to rearrange this. So I get cos squared of y equals 1 minus sine squared of y. So then cos of y equals the square root of 1 minus sine squared. So I could rewrite that as sine y squared. But what is sine y? We said earlier, it's x, okay? This is literally, it's crazy because all you have to do, you're given everything, x squared, and that's how you prove it, okay? So therefore, 1 over the square root of 1 minus x squared, okay? You have everything you need. You just have to show it, okay? And they might give you a few other ones to do. So just watch out for any of those. And, you know, they love to do, like an equation has this, you know, find, you know, like x squared sec 3x. Okay, product rule, go. Remember, sec is in the formula sheet, yeah? E to the tan x over cos of x. Don't forget, this is product rule and chain, yeah? Then here we have quotient rule and chain rule, okay? So make sure you scrub up on those. And then it might even say, for example, find the equation of the tangent. You do the exact same thing as in P1 and P2, just find the function of the gradient. That is what is going to help you here. Okay, so integration. I think this one's an easy chapter. So integration, first of all, we have the same with the sine, cos, minus sine, minus sine, cos, minus sine, minus cos, apart from when we integrate. So when we're integrating with these, instead of going clockwise, we go anti-clockwise. So sine integrates to minus cos, etc. Now, with the chain rule, with integration, instead of multiplying by the differential, we divide by the differential. So what I mean by that, for example, let's integrate sine 4x with respect to x. So if I have to integrate sine integrates to minus cos, okay? So that's minus cos of 4x. Now, 4x is chain rule, so I divide by the differential of that. What's the differential of 4x? 4, okay? And then remember, it's back plus c. We didn't see that in P2, but it's back with a vengeance. If, though, you have your limits, you know, of 10 and 2, if you integrate, you do not have to write plus c. They love using, in this one, what's called assumption. You don't know unless you've done P4. A lot of you redoing P3 now have done P4 though, so you can do integration by assumption or you can do by parts. Now, assumption is where you look at what is being integrated, okay? So, for example, they want you to integrate between 4 and 0 of 5 sec x, 5 tan x sec to the power of 4x, okay? So you're looking at this and you're like, oh my god, I don't even know how to do that, because this is essentially a product. We don't know how to integrate products yet. So what we do is we assume, what do I know? I know this is in the integral of sec squared is here. And what do I get? Tan kx. But that's not going to help us, right? I actually need the differential slide for here. I have to think, okay, what would differentiate this? So I think y equals what would differentiate this? Now, I know that when y equals sec squared of x, that when y equals sec x, I know I differentiate to the sec x tan x, right? So surely then sec to the power of 4, I could say, right, well then does sec to the power of 4x, let's let y equal that. What do I get here? What is sec to the power of 4x? A differential of sec to the power of 4x is essentially, this is sec x to the power of 4, right? So I bring the power down, 4 lots of sec x to the power of 3, and I multiply this by the differential of sec x. The differential of sec x is given to me in the formula book. I get my sec x, tan x, so I get 4 sec to the power of 4x tan x, okay? Now I can see, so this is what my y needs to be, apart from the fact that I have 5, I want 5, I've currently got 4. So what do I need to do? I need to multiply this by 5/4. So actually that means my y is going to be by 5/4. So when I then integrate it, I'm going to get 5 over 4 sec to the power of 4 of x in between 4 and 0. This is assumption. It's like working backwards, okay? It's practically differentiation. Oh yeah, and one last thing, sorry. When we're integrating, for example, brackets like 4x plus 2 to the power of 5, yeah? And even integrating e of x, or like integrate, when we have integrate with the chain rule, when we integrate e to the 4x, this is e to the 4x divided by 4 instead of the multiplied, right? And this again, we're going to increase the bracket by 1, 6, divide by the new power 6, but we also need to divide by the differential of 4x plus 2, which is 4, okay? So make sure you don't get caught out by that. Last one, numerical roots, probably the easiest chapter, numerical roots. Okay, what do you need to know for this one? How do you know if a root lies in between? You substitute in both values and then you're going to get a change of sign, right? So you substitute in both values, maybe you get x equals 2 and x equals 1, and then when you substitute this in, you'll get a negative number and a positive number, and then you have to write a sentence, something like remember this word, continuous. You have to write continuous, obviously, if it's continuous, and opposite signs, you have to write opposite signs. Therefore, root lies between, okay? But you have to write the word continuous as well, and one positive, one negative, or something of this form. Then sometimes it might ask you to rearrange, when it has like xn plus 1, and you've got to rearrange it, and there'll be like the x cubed here, etc. You'll be able to see from the question. That is common sense. Then lastly, if it tells you x1 equals something, and then you want xn plus 1 equals, you literally, whatever x plus 1, if this equals 5, I put 5 into my calculator, press equals, and then in here, in the next one, wherever it says xn, in my calculator, I'd put brackets and I'd put ants, and then I just keep pressing equals, equals, equals. I've done a video on this in morphing, but this is just like a literal quick overview, okay? Good luck for your exam. Please watch P1 and P2 recap, because you will need any of that. And just remember, do your best. You have got this.